Okay, Walker, segment 1, satisfactory factoring. Factoring polynomials to identify zeros. The student works 1, 2, 3, and 4. All right, let's take a look at the next page. Go ahead and mark this page off. All right. Go ahead and mark this page out as well. Activity 1.1, factoring out a GCF. Throughout your previous mathematical courses, you have applied the idea that a whole number can be decomposed into a product of its factors to solve a variety of problems. In this lesson, you will explore different methods of decomposing a polynomial into a product of its factors. Once you have factored a polynomial, you can use the factors to identify the zeros and then use the zeros to sketch a graph. To begin factoring any polynomial, always look for a greatest common factor, GCF. You can factor out the greatest common factor of a polynomial and then factor what remains. Factor out the greatest common factor. Okay, so we're going to factor out a 3 by dividing everything by 3. 3 divided by 3 is 1x squared. 12 divided by 3 is plus 4. I'm sorry, that should be a cubed. 4x squared minus 12x equals 0. Now you factor out the greatest common factor. Let's go ahead and factor this. We see that they all have an x, so we can factor out an x, which leaves 1x squared plus 4x minus 12 equal to 0. All right, now we know 2 parentheses. X and x makes x squared. Now we need to figure out what numbers multiply to give you negative 12 combined to be 4. Since the middle number is positive, the bigger number is going to be positive. So negative 1 times 12 is negative 12. Negative 1 plus 12 is 11. That doesn't work. Negative 2 times 6 is negative 12. Negative 2 plus 6 is 4. So that works. So our factors are x minus 2, x plus 6. So now we set them equal to 0. So x equals 0. X minus 2 equal to 0. X plus 6 equal to 0. Add 2 to both sides. You get x equals 2. Subtract 6 from both sides. You get x equals negative 6. So there are your zeros. Okay. So to graph them, well, there's 0. There's 2. And there's negative 6. Now to sketch the curve, we're going to use Desmos. So we're going to graph 3x cubed plus 12x squared minus 36x. And we need to zoom out. And we can see it's increasing starting on the left and on the right. And then we have the curve right there. So our sketch of a graph looks like this. All right, go ahead and finish that up. All right, let's take a look at the next page. Factor each polynomial function and identify the zeros, then use the factors to sketch a graph of the function defined by the polynomial. All right, like the previous example, we can divide each of the terms by 3. So then that's 1x cubed plus 1x squared minus 2x equal to 0. And then we can factor out an x from each term, so that becomes x times x squared plus 1x minus 2 equal to 0. So 2 parentheses, x and x. Now we need to figure out what numbers multiply to give you negative 2 combined to be positive 1. Since the middle number is positive, the bigger number is positive. So negative 1 times 2 is negative 2. Negative 1 plus 2 is 1. So that works. So our factors are x minus 1, x plus 2. So x equals 0, x minus 1 equal to 0, x plus 2 equal to 0. So add 1 to both sides, x equals 1. Subtract 2 from both sides, x equals negative 2. So we have 0, 1, negative 2. And let's get your graph. We're going to graph that in Desmos. So 3x cubed plus 3x squared minus 6x. So we can zoom out and we can see our curve there. All right. Go ahead and finish that up. All right, let's take a look at B. So we can divide every term by 2. That becomes 1x squared plus 3x equal to 0. We can factor out an x, which leaves x times x plus 3 equal to 0. So then you get x equals 0, x plus 3 equal to 0. So subtract 3 from both sides, get x equals negative 3. So we have 0 and negative 3. All right, and let's go ahead and sketch that graph in Desmos. All right, go ahead and finish that up. All right, let's take a look at C. So we can divide each term by 3. So then that's 1x squared minus 1x minus 2 equal to 0. So 2 parentheses, x and x. Now we need to figure out what two numbers multiply to give you negative 2 combined to be negative 1. Since the middle number is negative, the bigger number is negative. Okay? So 1 times negative 2 is negative 2. 1 minus 2 is negative 1. So that works. So our factors are x plus 1, x minus 2. So x plus 1 equal to 0, x minus 2 equal to 0. Subtract 1 from both sides, x equals negative 1. Add 2 to both sides, x equals 2. So negative 1 and 2. All right, let's go ahead and sketch that graph in Desmos. All right, there's your sketch of your graph. All right, let's take a look at the next example. So we can divide all the terms by 10. So that becomes 1x squared minus 5x minus 6 equal to 0. 2 parentheses, x and x. Now we need to figure out what numbers multiply to give you negative 6 combined to be negative 5. Since the middle number is negative, the bigger number is negative. So 1 times negative 6 is negative 6. 1 minus 6 is negative 5. That works. So our factors are x plus 1, x minus 6. So x plus 1 equal to 0, x minus 6 equal to 0. Subtract 1 from both sides. X equals negative 1. Add 6 to both sides. X equals 6. So, all right, let's go ahead and sketch that in Desmos. There you go. Go ahead and finish it up. All right, let's take a look at the next page. Go ahead and mark this page out. Right. Analyze each expression. Sort each expression based on whether it can be factored over the set of real numbers or over the set of imaginary numbers. So, all right. So, real factors are b, d, and e. So let's go ahead and factor those. So in this case, we don't have to factor. We can actually solve. So we're going to add 4 to both sides. You get x squared equals 4. Take the square root of both sides. Remember, square root is plus or minus. So this square root cancels squared, so you get x equals plus or minus 2. So x equals 2 and x equals negative 2. All right, let's take a look at D. So 2 parentheses. X and x. Now we need to figure out what numbers multiply to give you negative 5 combined to be positive 4. Since the middle number is positive, the bigger number is positive. So negative 1 times 5 is negative 5. Negative 1 plus 5 is 4. So that works. So our factors are x minus 1, x plus 5. So x minus 1 equal to 0, x plus 5 equal to 0. Add 1 to both sides, x equals 1. Subtract 5 from both sides, x equals negative 5. Okay, E. Now, whenever you have a negative in front of the x squared, you want to divide everything by negative 1 to get rid of that negative 1 to make it easier to factor. So we're going to divide everything by negative 1. So that becomes a positive 1x squared minus 1x minus 12 equals 0. Okay, so 2 parentheses, x and x. Now we need to figure out what numbers multiply to give you negative 12 combined to be negative 1. Since the middle number is negative, the bigger number is negative. So 1 times negative 12 is negative 12. 1 minus 12 is negative 11. That doesn't work. 2 times negative 6 is negative 12. 2 minus 6 is negative 4. That doesn't work. Okay. 3 times negative 4 is negative 12. 3 minus 4 is negative 1. That works. So our factors are x plus 3, x minus 4. So x plus 3 equal to 0, x minus 4 equal to 0. subtract 3 from both sides, get x equals negative 3. Add 4 to both sides, x equals 4. Right, go ahead and finish it up. All right, now let's take a look at when it's imaginary factors. So we're going to subtract 4 from both sides. You get x squared equal to negative 4. Take the square root of both sides. Remember, square root's plus or minus. Square root cancels the squared, so you get x equals, now square root of negative number is imaginary, so plus or minus 2i. So x equals 2i, and x equals negative 2i. All right, go ahead and finish it up. All right, let's take a look at the next page. The student can factor using the chunking method, but the teacher will be factoring with the reverse box method. So you're welcome to read this and this if you want to understand the chunking method. Otherwise, I'm going to move on and explain this using the reverse box method. All right. Using chunking, factor and identify the 0 of f of x equals 25x squared plus 20x minus 21, then sketch the polynomial graph. So reverse box method, so we have 25x squared and negative 21. These need to combine to be 20x. Now, to get 25x squared, I know I can multiply 5x and 5x. And now I need to figure out all the combinations that give me negative 21. So negative 20 or negative 1 times 21 is negative 21. Negative 2 doesn't work. Negative 3 times 7 equals negative 21. Negative 4 doesn't work. Negative 5, negative 6, negative 7 times 3 is negative 21. And then we know that negative 21 times 1 is negative 21. So one of these combinations should work. Let's try negative 1 and 21. So negative 1, 21. 5x times negative 1 is negative 5x. 21 times 5 is 65x. This is nowhere near 20, so I know that this doesn't work. So now let's try the next one. So it's a little bit of trial and error, but it eventually works. So now let's try negative 3 and 7. So minus 3 and 7. So 5x times negative 3 is negative 15x. 7 times 5 is 35x. 35 minus 15x is 20x, so this works. So we have 5x minus 3 times 5x plus 7 equal to 0. So 5x minus 3 equal to 0. 5x plus 7 equal to 0. So we add 3 to both sides. You get 5x equals 3. Divide both sides by 5. X equals 3 fifths. And it's a fraction, we don't care. Positive side, negative side. So 3 fifths is right here. And then here we subtract 7 from both sides. You get 5x equals negative 7. Divide both sides by 5. X equals negative 7 fifths. We don't care, it's a fraction, it's negative, so it's on this side. All right, and then let's go ahead and graph the equation in decimals to find our curve. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, go ahead and mark that out. A special form of a polynomial is a perfect square trinomial. Perfect square trinomial has first and last terms that are perfect squares, and a middle term that is equivalent to 2 times the product of the first and last term square roots. Factor of perfect square trinomial can occur in 2 forms. A squared minus 2ab plus b squared is factored to be a minus b squared, and a squared plus 2ab plus b squared equals a plus b squared. Determine which of the polynomial expressions is a perfect square trinomial and write it as a square of a sum or difference. If it is not a perfect square trinomial, explain why not. A. This is not a perfect square trinomial because the last term is negative. B. This is not a perfect square trinomial because the middle term is negative 40x and not negative 80x. All right, take a look at C. So we see that the first term is squared and the last term is squared. So we know that A is 8x because 8x squared is 64x squared. And B is 2 because 2 squared is 4. Okay, so then this would factor to be 8x minus 2 squared. Okay, now we see we have our first term is squared, last term is squared. So A would be 3x squared and B would equal 1. So this would factor to be 3x squared plus 1 squared. All right, go ahead and finish that up. Now, before we move on, let's go ahead and check to make sure that this matches this. So we have 8x minus 2 squared is equivalent to 8x minus 2 times 8x minus 2. So let's go ahead and FOIL that out. 8x times 8x is 64x squared. 8x times negative 2 is negative 16x. Negative 2 times 8x is negative 16x. Negative 2 times negative 2 is a positive 4. So that simplifies to be 64x squared minus 32x plus 4. So you can see that this is a factor of this. All right, let's go and check out D. So 3x squared plus 1 squared is equivalent to 3x squared plus 1 times 3x squared plus 1. So let's FOIL that out. 3x squared times 3x squared is 9x to the fourth. 3x squared times 1 is plus 3x squared. 1 times 3x squared is plus 3x squared. And 1 times 1 is plus 1. So that simplifies to be 9x to the fourth plus 6x squared plus 1. So you can see that this is a factor of this. All right, go ahead and finish it up. All right, let's take a look at the next page. All right, we're going to mark off this section. And let's take a look here. Explain the steps to factor the polynomial expression by grouping. Step 1, factor out an x squared from the first two terms and a negative 1 from the last two terms. So if we factor out an x squared, that becomes x squared times x plus 3. And if we factor out a negative 1 from these terms, that becomes negative 1 times x plus 3. Step 2, factor out the binomial x plus 3 from the two terms. So since they're both multiplied by x plus 3, we can rewrite this as x squared minus 1 times x plus 3. Okay. Step 3, factor x squared minus 1 using the difference of squares. So this factors to become x plus 1, x minus 1. So this becomes x plus 1 times x minus 1 times x plus 3. All right, go ahead and finish that up. Now, use the factors to identify the zeros. So we have x plus 1 equal to 0, x minus 1 equal to 0, and x plus 3 equal to 0. So subtract 1 from both sides, x equals negative 1. Add 1 to both sides, x equals 1. And subtract 3 from both sides, x equals negative 3. So negative 3, negative 1, and 1. All right, and let's use Desmos to get the sketch of our graph. So x cubed All right, there you go. Go ahead and finish it up. All right, let's take a look at the next page. 5. Use factor by grouping to factor and identify the zeros of f of x equals x cubed plus 7x squared minus 4x minus 28, then sketch the polynomial. So we can factor out an x squared from the first two terms, which leaves x plus 7. And we can factor out a negative 4 from the second two terms, which leaves negative 4 times x plus 7 equal to 0. So then that becomes x squared minus 4 times x plus 7 equal to 0. Well, x squared minus 4 is a difference of squares, so that becomes x plus 2, x minus 2 times x plus 7 equal to 0. So x plus 2 equal to 0, x minus 2 equal to 0, and x plus 7 equal to 0. So we subtract 2 from both sides, you get x equals negative 2. We add 2 to both sides, you get x equals 2. And subtract 7 from both sides, you get x equals negative 7. So negative 7, negative 2, and 2. Let's go ahead and graph that to get our curve. All right, go ahead and finish it up. All right. Factor the polynomial expression x cubed plus 2x squared plus 4x plus 8 by grouping. Okay, so we can factor out an x squared, which leaves x plus 2. And we can factor out a plus 4, which leaves x plus 2, which becomes x squared plus 4 times x plus 2. All right, go ahead and finish that up. All right, let's take a look at the next page. Some degree 4 polynomials written as a trinomial ax to the fourth plus bx squared plus c have the same structure as quadratics. When this is the case, the polynomial may be factored using the same methods you would use to factor a quadratic. This is called factoring using quadratic form. All right, you can read over the worked example. Let's take a look at number 7. So factor each polynomial over the set of complex numbers using the factors to identify the zeros and then sketch the polynomial. So we can factor out an x cubed from the first two terms, which leaves x minus 4. And we can factor out a negative 1 from the second two terms, negative x, which leaves x minus 4 equal to 0. So then that factors to be x cubed minus 1x times x minus 4. Now we can factor an x from each of these terms, so that becomes x times x squared minus 1 times x minus 4 equal to 0. So x equals 0. x squared minus 1 equal to 0, and x minus 4 equal to 0. So we add 1 to both sides. You get x squared equal to 1. Take the square root of both sides. So then x equals plus or minus 1. So x equals 1, x equals negative 1. And then add 4 to both sides. X equals 4. Okay, so we have negative 1, 0, 1, and 4. All right, let's go ahead and sketch that in Desmos. All right, go ahead and finish up that. All right, let's take a look at the next example. All right, here we have three terms, 2 parentheses. We know, in this case, x squared, x squared. Now we need to figure out what numbers multiply to give you 9, combined to be negative 10. The only combination that would work would be negative 1 times negative 9 is positive 9. Negative 1 minus 9 is negative 10. So our factors are x squared minus 1, x squared minus 9. So x squared minus 1 equal to 0, x squared minus 9 equal to 0. Add 1 to both sides, you get x squared equals 1. Take the square root of both sides. X equals plus or minus 1, so x equals negative 1, x equals 1. Add 9 to both sides. Get x squared equal to 9. Take the square root of both sides, so x equals plus or minus 3. So x equals negative 3, and x equals 3. So we have negative 3, negative 1, 1, 3. Let's go ahead and sketch that in Desmos. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, go ahead and mark that page out. All right, factor the polynomial. So, first term, 3x squared. Last term, negative 8. And these need to combine to be 2x squared. Now, 3x to the fourth. Now, to get 3x to the fourth, we can use 3x squared and 1x squared. Now we need to figure out what combinations multiply to give you negative 8. The only combination is negative 1 and 8 and 1 and negative 8. So let's try negative 1 and 8. So 1, that's negative 1x squared. 8 times 3 is 24x squared. That does not combine to be 2, so that doesn't work. So now let's try a positive 1 and a negative 8. Okay, so then that's 1x squared, negative 24x squared. So that doesn't work. So the 1 and 8 combination doesn't work. So now let's try plus 2 minus 4. Okay, so 1x squared times 2 is 2x squared. Negative 4 times 3 is negative 12x squared. That doesn't combine, so let's try switching these. So let's try minus 4, positive 2. So 1x squared negative 4 is negative 4x squared. 2 times 3 is 6x squared. 6x squared minus 4x squared is 2x squared, so this works. So our factors are 3x squared minus 4 times 1x squared plus 2. All right, go ahead and finish that up. All right, let's take a look at number 2. So we know 2 parentheses equal to 0, x and x. Now, we need to figure out what numbers multiply to give you positive 36 combined to be negative 12. So since the middle number is negative, the bigger number is negative. So 1 times negative 36. Now, wait a second. In order to get a positive, both numbers have to be negative. So negative 1 times negative 36 is positive 36. Negative 1 minus 36 is negative 37. That doesn't work. So let's try negative 2 times negative 18 is positive 36. Negative 2 minus 18 is negative 20. That doesn't work. Okay? So now let's try negative 3. Negative 3 times negative 12 is positive 36. Negative 3 minus 12 is negative 15. That doesn't work. Okay, let's try negative 4 times negative 9 is positive 36. Negative 4 minus 9 is negative 13. Doesn't work, but we're close. Let's try another combination. Negative 5 doesn't work. Negative 6 times negative 6 is 36. Negative 6 minus 6 is negative 12. That works. So our factors are x minus 6, x minus 6. So x minus 6 equal to 0, x minus 6 equal to 0. So add 6 to both sides, x equals 6. Add 6 to both sides, x equals 6. Let's take a look at the next example. So we can factor out an x squared from the first two terms, which leaves x plus 2. And then we can factor out a 7 from both those terms, so that's 7 times x plus 2. So this factors to be x squared plus 7 times x plus 2. All right, go ahead and finish up 1, 2, and 3. All right, let's take a look at number 4. So first term is 25x squared. Last term is negative 7. And these need to combine to be negative 30x. Okay, so to get 25x squared, we know we can use 5x and 5x. So now let's try a positive 1 and a negative 7. So 5x times 1 is 5x. Negative 7 times 35 is negative 35x. This combines to be negative 30x. So then our factors are 5x minus 7 times 5x plus 1. All right, number 5. So we can actually factor out a 2x squared from all the terms, which leaves 1x squared plus 5x plus 6. Well, 2x squared, 2 parentheses, x and x. Now, the numbers that multiply to give you 6 and combine to be 5 would be plus 2 and plus 3. Because 2 times 3 is 6. 2 plus 3 is 5. All right, go ahead and finish it up. Let's take a look at the next example. All right, the student works 1A, 1B, 1C, 1D, 1E, 1A, and 1B. And then go ahead and mark off this page, start working on your assignment, and have a wonderful Wildcat day.